All right, this is the video that goes with the cumulative review packet number 8 for Algebra 1. I'm Mr. Foster, so I'll be covering the first 5 problems, so the first 2 pages. And then Mr. Lakin will take over, and then you'll hear from Mrs. Locus. All right, so we're going to start with this word problem that we have to convert to a system of equations. And what we want to notice is a couple things. What are they telling us, and what are they asking us? They're telling us that a package of hot dogs costs $1.60 and a package of hamburgers costs $5. And then they want to know if you need to buy 8 packages total and you spend $23, then how many packages of each will you buy? And this part right here, how many packages, ooh, got the wrong button working. This question, how many packages of each will you buy? That's going to guide us on answering this labeling of variables, because how many is what needs to be mentioned here. So we're going to say that variable x is going to be how many packages of hot dogs. So number packs of hot dogs. And y is going to be number of packages of hamburgers. So we've labeled our variables. Now we're going to set up the system of equations. So what do we know? We know that a package of hot dogs is $1.60. We know the number of them is x. So if we take the number of packages times $1.60, so 1.6x plus the number of packages, the number of packages of hot dogs times 5. So 5 times the number of hamburger packages. All that's going to end up being $23. We also know that we have a total of 8 packages. So if we just add up the number of packages of hot dogs plus the number of packages of hamburgers, we have 8 total. Now we have our system of equations and space to solve. I just got to make a little more room to slide down here. So what we know so far is that we have this system, but we need to eliminate one of the variables, or we need to substitute. So I think in this case, since they're both in standard form, we'll go ahead and use elimination. And in this case, I can see that I have 5y in one and y in the other. So the simplest way I can think of is just to multiply this bottom equation times -5. And then when we do that, I'll rewrite the top equation, 1.6x plus 5y equals 23. And then if I multiply -5 times each of these pieces, I have -5x minus 5y, which will eliminate the y, equal -40. And then we can just add straight down, which gives us 1.6 minus 5 is -3.4x. 5y minus 5y is 0, and that equals -17. 23 minus 40 is -17. Now if we divide both sides by the 3.4, -3.4, we end up with x equals 5. So that's half of our solution, but we need to find the y coordinate. And then we can use this same equation, x plus y equals 8, but we'll substitute 5 for the x. So we'll say 5 plus y equals 8. Subtract 5 from both sides. Y equals 3. So the final answer is 5 packs of hot dogs and 3 packs of hamburgers. We answered the question that they asked. Okay, if you need more time to review that, go ahead. Hit pause, I should say. Otherwise, we'll move on to number 2. All right, number 2 is another system of equations word problem. This one's also about food. 2 bagels and a glass of juice cost $1.20. 3 bagels and 2 glasses of juice cost $2.05. Find the cost of a bagel. So this is our clue. Find the cost of a bagel and the cost of a glass of juice. So that tells us our variables. So I'm going to say x is the cost of a bagel. And y is the cost of a glass of juice. So now we set up our system. If we have 2 bagels, that's 2 times the cost of a bagel, so 2x plus 1 juice equals $1.20. Also, 3 bagels, so 3x, and 2 glasses of juice, 2y, equals $2.05. Now we have our system set up, but we just need to figure out how to eliminate. In this case, wouldn't it be simple to just take the top equation times -2, which would then cause the y to be -2, and the bottom equation would have +2, so the y's would go away. So that's what we'll do. So we're multiplying all that by -2. When I do that, I'm going to get -4x minus 2y equals -240. And then I can just carry this one straight over, which was 3x plus 2y equals 205. Then when we add straight down, the y's go away. We have -x equals -0.35. It's a point. And then we divide both by -1. So we can solve just for x. We have x equals 0.35 or 35 cents. And then all we can do is plug this 0.35 back in for x, which we'll do now. So I'm going to rewrite that original equation, except instead of x, I'm going to put 0.35. So it's going to be 2 times 0.35 plus 1y equals 120. So that's 0.70 plus 1y equals 1.20. Then if we just go ahead and subtract 0.70 from both sides, we end up with 1y equals 0.50. So then to go ahead and answer the question, a bagel costs 0.35 or 35 cents, and a glass of juice costs $0.50 or 50 cents. That's it for number 2. Hit pause if you want to look back over that, or we'll move on to number 3. So in number 3, we're given these functions, f of x and g of x. So f of x equals 3x minus 2. G of x equals x squared plus 6x. And then we're asked to solve these two equations, or these two problems. 3 times f of negative 8 plus 5 times g of 2. So we just have to break this into parts and take care of it. And then we'll be substituting in the negative 8 for the x here, and the 2 for the x's here, because this is g of x and this is f of x. So the way that'll look is 3 times f of x. So that's 3 times negative 8 minus 2, all of that plus 5 times g of x, which is plugging in the 2 for the x's here now. 2 squared, that should always be in parentheses, plus 6 times 2. Alright, so we're going to solve inside the parentheses. So it's 3 times negative 24 minus 2 plus 5 times 2 squared is 4 plus 6 times 2 is 12. Keep simplifying. 3 times negative 26 plus 5 times 16. And then we find that 3 times negative 26 is negative 78. That's a 7. Plus 5 times 16 is 80. And then when we add those together, we get 2. So the solution here is 2. All right, hit pause if you want to. Otherwise, we're going to slide over and do this second problem, B. Just draw a line between them. And here we go. This time we have g of f of 4. So we need to solve for f of 4, putting 4 in for the x here. And then whatever that is, we're going to substitute that value in for g of x. So f of 4 is 3 parentheses 4 minus 2, or 12 minus 2, or 10. So f of 4 is 10. Now we take that value and we plug in that 10 for g of, so we have g of 10 equals 10 squared plus 6 times 10. All right, so g, actually it's g of f of 4. Bottom line, this is 100 plus 60, or 160. Hit pause if you need to, otherwise we'll move on to number 4. All right, in number 4, we're given this problem and asked, where we're given these 5 coordinates, 2, 5, 4, negative 2, 3, 3, 5, 4, and negative 2, 5, where the first is the x value and the second is the y. We're asking what's the domain and the range of the following. So in this relation, the domain is all of the x values, the 2, the 4, the 3, the 5, and the negative 2, in order from smallest to largest. So our domain will be negative 2, 2, 3, 4, 5. And then our range is all of these y values in order. So 5, negative 2, 3, 4, and 5. again in order from lowest to highest. So that gives us -2, 3, 4, and 5. And though we have 2 5s, we don't list them as duplicates. We just write it the one time. And then based on these points in this data, we're asked, is this relation a function? And very simply, it is. So we're going to say yes. And the reason for that is that, first of all, none of the x values are duplicated. And so for every x, there is only one unique y value. So we don't have two different x values that are the same with different outputs or y values. And then the last part of this says, if it is a function, which it is, let's add a point that makes it not be a function. And very simply, all we have to do is take any of these x's that we've already used, such as, let's take that 0.225. I don't know why it's jumping around on me. So we'll take the 2, 5, and then we'll add another point, say 2, 6. If you add that, not a function anymore because we have the same input of 2, but we're getting 2 different outputs. All right, that's it for number 4. So pause if you need to think that one over. Otherwise, we'll move on to the last one for me, number 5. And so for number 5, this should be pretty quick. We just have these 3 different, we have a graph, we have a table, and then we have a chart. I forget what those are called. But actually, we're just asked, is it a function? And then yes or no, and then explain why or why not. So in this first one, in A, we're just looking, and I'm thinking, if we just use the vertical line test, draw a vertical line, well, we see it hits twice. And that when it fails the vertical line test, that means we have 2, so it's no, and we have 2 different outputs or different y values for the same x value. Because we look here like -2, it crosses at, it looks like +2 and at -4. So that's no go. No bueno if you're looking for a function. All right, the second table here, we have inputs of 2, 4, 5, and 7, and then so outputs of -1, 2, -6, and 1. And again, because it is a function, yes, and the reason is, first of all, none of the x's are duplicated, and so if they're not repeated, it has to be a function because we can't have any conflict with the y. So the reason that it is that for every x, we have a unique y value. Only one y value. And lastly, in this diagram, we have inputs of 4, 6, and 7, but we see that the 4 goes to the 2 and to the 5. So if we listed those as coordinates, it'd look like this: 4, 2, 4, 5. And you could say stop right there, that's a problem. And then we have 6, -1, and 7, 3. So the issue is right here. And the fact that we have a 4 with a 2 output and a 4 with a 5, it's not good. So this is not a function, no. And the reason is that we have 2 different outputs for the same X input. Make sure you're specific like that. Don't just say over here that it failed the vertical line test. Say what that shows us. It shows us that there's two different Y values for the same X. All right, that's it for my part. Good luck with the test. Hope to see you at PLT if you need any help with this, or even in class. Don't hesitate to ask us. Good luck the rest of the way. Thanks for listening. Bye-bye.